Guys, welcome to the last week of school. We are finally done with this mess. This week, the new content that we're talking about is again factoring. I'm actually going to go over some what they call special cases of factoring, things that we should be able to recognize quickly and easily in order to factor things quickly and easily. Last week, we talked about the X box where we set it up where we could break down quadratics, which means our variable was squared, into um, smaller variables. We're doing the same exact thing. These are just special cases. Okay, so the first one I want to talk about is the easiest one to spot because all of the problems from last week's assignment had three terms in them. And so we were able to take the middle term, the first term and the last term went in the top and bottom corners of our boxes. And then we did the X where the top number was the last number, the bottom number was the middle number, and we multiplied two numbers to get the top number and added two numbers to get the bottom number, and those were our two terms. Now, the first case that we're going to talk about today is called the difference of two squares. And the reason that it's known as the difference of two squares is because it's always the difference meaning subtraction. There's two terms instead of three terms like we had last time, and both of the values are perfect squares. Of course, x squared is easy to spot because x squared is x squared, so of course that's a square. The number is sometimes a little harder to remember, but remember we had a quiz on this before we left for coronavirus vacation where you should remember all of the perfect squares. And we've got 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 400, 625, all of those perfect squares that we memorized. If that's one of our numbers, and there is subtraction in between another perfect square, that means we have this special case known as the difference of two squares. And the way that this factors out, we can still do the X box, but we have to look at it a little bit differently. Because if we're going to factor this, we have to write it out like we looked at last week. Okay, and we always had three terms in the way we did it last week. So we're going to do it the long way first, and I'm going to show you the quick way to do it, and the way I want you to see it in the future. Okay, so this is actually the same term or the same type of term that we factored last week. You'll notice we only have two terms because the middle term is basically 0. So we can rewrite this x squared plus 0x minus 16. These two things are the same thing. But 0 times x is just 0, so we don't have to write it because 0 minus 16 is still negative 16. Okay, but if we were to factor this term right here, I would do my x in my box, and in my box I'd have my first term and my last term, right? Okay, now in my x, remember my last number goes first, so I'd have negative 16, and then in my bottom I would have the middle term, 0. So what two numbers multiply together to give me negative 16, but when I add them together, they add up to be 0. We glanced on this just a little bit, but just a reminder, if this number is negative, that means one of these numbers has to be positive and one of these numbers has to be negative in order to get a negative. And the quick answer is negative 4 and 4 are the two numbers. Negative 4 times positive 4 is negative 16, and then 4 minus 4 is 0. Okay, so that means these terms are negative 4x in my box and positive 4x in my box. So that means, factoring this out, x times x gives me x squared. Then what value would multiply times this x to give me 4x? That'd be a positive 4. And what value multiplies times this x to give me a negative 4x? That would be, of course, negative 4 times x gives me negative 4x, and then negative 4 times positive 4 is negative 16, so my box is complete. So that means x squared minus 16, or x squared plus 0x minus 16, if we factor it with the x box, would be x plus 4 times x minus 4. Okay, so this is the correct answer. Now, the reason that we're looking at this, and I told you earlier we're going to look at this so that we can do it quicker, is we don't have to do all of this to get this answer. There's a quicker way to factor these things if you recognize them. Okay, so I'm going to erase all of this middle stuff. I'm going to leave the answer down at the bottom because that is the correct answer. Now, the easiest way to do the difference to factor the difference of two squares is to simply take the square root, or what number squared gives me these two values. Well, what value squared gives me x squared? Well, of course, that's x. And then what value squared gives me 16? Well, 4 squared is 16, so that's 4. Every single difference of two squares has x in the first term, whatever the square root of the first term is, and whatever the square root of the last term is. So I can rewrite this as x plus 4 and x minus 4. It works like this every single time because the middle terms have to cancel out, so these numbers have to be the same. Okay, let me show you another example. If I have y squared minus, we'll do 36. Again, this fits my criteria because I have the difference, two values, and both of the values are perfect squares. 36 is 6 times 6, and y squared is y times y. So to factor this, instead of going through the whole x box mess, I recognize it's two terms. I have the difference, it's subtraction. These are both perfect squares, so I can write the square root of the first term twice, and then the square root of the second term twice, and then plus in one, minus in the other. Every single difference of two squares problem factors out just like this. You take the square root of each of the terms, one of them has a plus in between them, one of them has a negative in between them. That's the simplest way that I can show you that. So be looking for that. Anytime something has two terms and it asks you to factor them, see if it's two perfect squares. Okay? And then that's the easy way to do it. You don't have to do any more work. Okay? Now, we skipped a step last week when we were talking about factoring because I wanted to get done with, not having a 45-minute video for you to have to watch. But there is a first step that you should always do whenever you're factoring. And that is you should always look and see if all of the terms have something in common. So if I have something like this, x cubed minus 3x squared plus, let's do 4x squared plus 3x. If I have a problem like this, the tendency is, well, I have three terms. It looks like the problems that I did last week, so I'm just going to go ahead and do that. The problem is there's no way that I can get factored down all the way because I have an x in all of my terms. So the first step of factoring is always see if there's, I call it a GCF, a greatest common factor. Is there something that every single term has in common? If the answer is yes, then I want to do that first, because that makes my life so much easier for the rest of the problem. Okay? So if I look at this, I see that there's an x here, there's three x's here, there's two x's here, and there's one x here, so I can factor out that one x. And when I take away one of the x's from here, this was x times x times x, but if I took one of them away, that means I have x squared. And then I had 2 right here, so now I'm down to 1x there. And then I had the 1x, I took it away, so I don't have any x's left there. Now I have a trinomial. That's what this is called because it's three terms. Tri means 3 3, and nomial doesn't mean anything, but that's just what they call it in math. But I have a trinomial here that I can factor. So I can do the X box on this. What two numbers multiply together to give me 3 and add together to give me negative 4? In my box, I have x squared first term, 3 in my last term. Okay, what two numbers multiply together to give me 3, but add together to give me negative 4? Well, what are the only two numbers that multiply together to give me 3? That's 1 and 3. 1 times 3 is 3, but this is a negative 4. So that means I have to have negative 3 and negative 1. Because negative 3 times a negative 1, negative times a negative is a positive. And then negative 3 plus a negative 1 is negative 4. So that means this is negative 3x and this is negative 1x. Okay? So again, what times what gives me x squared? That's always x and x. Anytime I have an x squared here, or a p squared, it would be p and p. J squared, it would be j and j. It's just how factoring works. Okay, what value times x gives me negative x? That'd be negative 1. And what value times x gives me negative 3x? That'd be negative 3. So now, I factored this x out, so it comes down in my final answer, and then I have x minus 1 times x minus 3. So this problem up here, x cubed minus 4x squared plus 3x, when it's completely factored, ends up being x times x minus 1 times x minus 3. Okay, so first step in factoring is always look and see if everything has a common term. Let's look at a problem that's going to look a little bit familiar. What would happen if I had x to the 5th minus 16x cubed? Now this looks familiar because it looks kind of like our difference of two squares problem that we started out with. But we have a problem. 16x cubed is not a perfect square. So I cannot factor this like the difference of two squares because this is not a perfect square and this is not a perfect square. However, they do have something in common. They both have x cubed in them. This one has 3 x's, this one has 5 x's. So if I factor out x cubed, then I'm left with x squared minus 16. Now I have something in the parentheses here that I can factor. So I bring down my x cubed, and then I have x plus 4 times x minus 4. So this right here would be my final answer because they had an x cubed in common. So I took it out, and then I factored what I had left, knowing what I just learned about the difference of two squares. Okay? I think that's all we're going to talk about. There is one more type of special case. It's a perfect square, but any perfect square that you're going to do, you can factor using the Xbox method. So I'm not going to worry about those on this video because it's already taken me almost 15 minutes to explain this, and I don't want to confuse you further, and there's a little bit of a process to identify those, and they're kind of hard to see, and I would want to be able to do a whole bunch with you, and since I can't really do that, I'm not going to go there. So on the homework tonight for this week, if you'll look at it, you'll see that there are some problems that are just some trinomials. I think one of them is like x squared plus 4x plus 4. Okay, if it doesn't have anything in common, and it's not just two terms that I can do the difference of two squares on, like we just talked about with x squared minus 16, then you're just going to go ahead and do the Xbox method on that. Find what two numbers multiply together to get the last number, and then add together to get the middle number, and that will give you your answer. Now, the problems on this, the two numbers will end up being the same. That they're called perfect squares. And hopefully you'll see the pattern, but it's not as important for you to be able to recognize those as it is the difference of two squares and finding the greatest common factors in the beginnings of the problem. So that's how that goes. Hope you guys are doing well. Hope you're enjoying your last week of official distance learning. Hopefully we'll be able to see you once school comes back around in August. See you guys.